Welcome back to another lesson from Soflex Math. Today we're going to be talking about converting mixed numbers to improper fractions. So a couple of different terms here, even in our title. First of all, from when we did our unit fractions, remember those were called proper fractions, where like 3/4, where the numerator was smaller than the denominator. Well, today we have something called a mixed number. So right here, over here, we have the mixed number. So we have a whole number, 3, and then a fraction, or a whole number and a proper fraction, 1/4. All right, so what we're going to do is we're going to convert that into something called an improper fraction. And an improper fraction means that the top number, the numerator, is actually going to be larger than the denominator, or greater than the denominator. All right, so what we're going to do is we're just going to take whatever our denominator is from our mixed number is going to be the same here as our denominator on our improper fraction. Okay, so we're going to do it two different ways. One, there's kind of some rules to follow, and then number two, we're going to use this picture down below to kind of show what that means. So what we're going to do is we're going to make a little times sign and a little plus sign and a little arrow like a smiley face. So this is the order that we multiply and add in order to get an improper fraction. So we do 4 times 3, which is 12, plus the numerator, 13. So the answer to this problem, if we were to convert the mixed number, 3 1/4, to the improper fraction, it would be 13/4. Notice how the numerator is now larger than the denominator. That's what makes it improper. If it was 4/13, that would be called proper. But let's take a look at our diagram here. And the key thing to remember from yesterday's lesson about representing wholes or representing 1 is that we could have the same number over itself. So if we have 4 and all 4 are colored in, so if these were all shaded in like so, we would have 4/4, and that's the same thing as 1. So each one of my rows here, these are all whole numbers. So what I've represented here is another way to represent our number 3, 4/4. So if we had, just so you can kind of see this, 4/4, 4/4, and 4/4. So if I asked you to write these as a fraction, you'd say there's 4 colored in over 4. So each one of those equals 1. So we have 1, 2, and 3. So there's our whole number 3. All right, this one over here that's colored in, all right, that's only 1 out of 4. So there's where our 1/4 is. All right, so the way you would solve this using the picture is you take this, you have 3, so all those together is 3, times how many parts? 4, and then you're just going to add whatever your fraction part is, or your numerator. So you do 3 times 4, which is 12, plus the 1 extra one here, and that's how you got your 13. And it's still over 4. It's still over 4 parts. So 4 times 3 plus 1, 4 times 3 plus 1. So you can even draw it out and make a diagram, or you can just kind of memorize our algorithm. All right, let's try a couple more just to see how that works. Okay, so this time we have 5 1/3. So we can write our denominator because it's still going to be out of thirds. And we're going to make our little symbols to help us. We're going to multiply, we're going to add, and we're going to start and go in that order. So 3 times 5 is 15. 15 plus 1 is 16. Pretty simple. So there's your answer, 16/3. Okay, here's our proof. So if we look at this section here, we have 1, 2, 3, 4, 5 holes. Okay, and they're each 3 high. Why? Because that's what our denominator, because 3/3 equals 1. 3/3 equals 1, so we have 5 of those, and then we only have 1 of our last one, which is representing our fraction, 1/3. 1/3. So 5 times 3 is the 15, plus the 1 extra gets us to our 16. All right, another way, if you can draw this, another way to do it is just to count. So you could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So you could even count them all up and then have them all out of the parts, and each part has 3. So that's another way you can do it. Obviously, that's not the most efficient way or the quickest way, but it is a way to check your work, especially when you're just starting out, to try to understand what's happening. So instead of just saying, oh, I'm going to multiply 3 times 5 plus 1, and then someone asks you why, and you have no idea, well, here's a little diagram. Here's where you could prove it, because you could say we have 5 rows that are 3 high, and then we add our fraction part, which is 1. All right, so let's take a look at another problem. We have 2 more to practice. All right, so today's example is 2 1/7. So once again, let me just put down an answer for you. And I want you to think to yourself how you got that. And I'm going to label it down here again. I want you to see if you can figure out why I'm putting these numbers where I'm putting them. So do you understand why there's a 2 down here? Do you understand why there's a 7 over here? Do you understand why I made 7 kind of rows or 7 cubes? Do you know why I just put 1 cube here? So those are the questions I want you to try to answer. I'll explain them one more time. So the algorithm, or the rules, are 2 times 7 plus 1, working your way around. So 7 times 2 is 14 plus 1 is 15. So there's our answer. All right, so here's our whole number 2. We draw 2 big columns, and we're going to use our denominator because 7 over 7 equals 1. So we're going to make sure that we always count up to make sure that we get to that number. So I count up to 7 because I know that 7 over 7 is equal to 1. Like I put a 1, 1, 2 down here. All right, and then I'm going to count this one up the same way. That's how you know how tall to make your drawings. Okay, 1, 2, 3, 4, 5, 6, 7 over 7. So once again, 7 over 7 equals 1. So here's 1, and here's 2, and then here's my 1/7. So I've represented every part of that mixed number. Okay, so we're just going to multiply our 2 rows of 7. That gets us to 14, plus our 1 left over, 15. All right, or you could just count them all up, 7, 14, and 15. Either way, you're going to, all 3 ways, end up with that same improper fraction answer. All right, last one we're going to practice. All right, all the previous answers or questions we've had just a 1 at the top is like 1/2, 1/3, 1/4. Now we're going to have a numerator that's a little different, but we're going to follow the same thing. So we'll get to our picture here in a minute, but let's take a look at this. So 6 times 4 plus 5. So just because it's bigger numbers, that shouldn't change anything. We're still dealing with 6 parts. So 6 times 4 is 24, plus 5 is 29. All right, so this time we're going to count the fraction has 5 parts. So the fraction is 5 out of the 6. Each one of these is 6 out of 6 if you colored them all in. So we have 1, 2, 3, and 4. There's our 4 holes, and we have our 1, 2, 3, 4, 5, and 6. So we have our 6 high for all those. So 6 times the 4 is 24, 25, 26, 27, 28, 29, 29 sixths. So as you go through the worksheet and the practice problems, you can try to just solve them using our formula kind of here of denominator times whole number plus numerator, or go ahead and try to draw out your pictures here. You can also use something called unifix cubes, and I'll try to remember to put a link down below. But unifix cubes or snapping cubes, you can put together, and then you can actually build these to represent them. So you can actually put them together, and then that might also help you to understand kind of the lesson. But once again, so this is converting our mixed number, a new word, to an improper fraction. That's what this lesson was. In our next lesson, we're going to go the other way. So we're going to take improper fractions and turn them into mixed numbers, and we'll kind of show you how to do that as well. Unifix cubes, though, are a great tool you can use to help you visualize it and use a concrete model to solve that. All right, so once again, thanks for watching Soflex Math, and we'll see you in the next lesson.